Okay, the concept of perimeter is one you'll be familiar with from many years of practice on it. So we're talking about the total distance around a shape's boundary for the perimeter of a shape. And I guess what we want to do today is we want to start to extend it to more complex shapes. So we're not going to do stock standard shapes so much. We're going to look at some more complex ones. So here we've got a shape like this, and one of the things I guess initially with perimeter is you want to make sure the units you've got your measurements in are all the same. So I've got 8 centimetres, 11 centimetres, 35 millimetres. So I'll need to do a conversion of my 35 millimetres back to centimetres. By now you know divide that by 10, so it's actually 3.5 centimetres. So if I want to find the perimeter of a shape, I simply add up all of the distances around. I've got 8 centimetres, I've got 11 centimetres, and then these markings, these same markings tells me these sides are actually equal in length. So I have 11 centimetres again. One here, one here. My 35 millimetres, which I know is 3.5 centimetres, again, the consistent marking tells me these shapes are all the same length. So I've got 3 lots of the 3.5 centimetres. Perimeter is just a matter of adding all that up, which gives us, what does that give us? 40.5 centimetres as the perimeter of that shape. Okay. Other shapes, such as these step shapes. So shapes with steps in them are interesting because there's actually a little bit of a cheat you can do for these step shapes, and that's the reason why I've got it here in this material. So if you have a look at this shape, we've got, assuming that these are all right angles in the corners, then what we've got here is we've got a little L shape. And so we've got 8 centimetres, 7 centimetres, 2, 3.5. We could work out these two. But as I said, with step shapes, you can do it as a cheat, because really a step shape, if I push this out, is just simply a rectangle. Okay, it's a bit wonky rectangle in this case. So realistically, if everything's a right angle in there, I've really got 8 centimetres, 7 centimetres times 2. So for my step shapes, rather than having to work out those missing lengths, I can simply say the perimeter is equal to 2 lots of the 8 plus the 7. And that's a little shortcut method to doing those, giving me 30 centimetres. So it works with these sorts of L-shaped ones where you can just keep pushing it out to make yourself into a square. Keep pushing it out, not necessarily a square, maybe a rectangle. Push it out like that. Alright. Not all of them, though, with these sorts can be pushed out. For instance, with this shape, I could push this up here, but I'd still be left with these extra boundaries here. So to find the perimeter of something like this, I need to work out the lengths of the sides. And again, the assumption is it's right angles as well. And so I've got my 7 metres, so I've got 2 lots of the 7 metres. And then I have this side here, this side, and this side. Now those 3 sides will be the same as that. So if I add them up, I've got 3 plus 3 plus 3. I've got 9 metres along the top, and I'm going to have another 9 metres along the bottom. So I've got these 4 sides covered. Don't forget these 2 little ones down here. So I've got 2 lots of 2 metres. So 14 and 9, 18 is 32, and another 4 makes 36 metres. So as long as you're making sure you've got all your sides covered, you're pretty well right. Maybe you're asked a worded question. Find the side length of a square whose perimeter is equal to that of a regular hexagon with sides 12 centimetres. So hexagon has 6 sides. So the perimeter of the hexagon will be 12 centimetres for each side times 6, or 72 centimetres. So that's the same as the perimeter of the square. So to get the side length of the square, well, a square doesn't have 6 sides, it only has 4. So the side length of the square then is going to be the 72 divided by the 4. If I do that, I get 18 centimetres as the length of the side of a square. Other shapes, like this one, find the perimeter of this particular shape here. So this time round, I've been given some information about this triangle, being isosceles triangle, but I haven't actually been given these two sides here. So I've got 18, 40. What happens in an isosceles triangle is the vertical here, this vertical line here, this will actually cut this bottom side in half. So if I take half one of those, I can see I've got a right angle triangle. This is 40, this is 9. This is the side I need to find before I can find the perimeter. So this side here, I'll call that X. Right angle triangle, I'll use Pythagoras. That'll be C, that'll be A, that'll be B down there. And so I'll come up here and I'll say, well, C squared is equal to A squared plus B squared. That working out we need to show. In this case, it's a hypotenuse is X. A I've said is 40 and B is 9. So I get X squared is equal to 1681 when I do that. So X must be equal to the square root of 1681. X will equal 41. So using this, I now have these two sides here, which is what I needed to find my perimeter. And so my perimeter is simply going to be equal to 41 plus 41 plus 18. So I get 82 plus 18 is 100 meters.